All right, so there's a new AI model on the block called UniWeTok, and it might just be a massive breakthrough in how AI learns to both see and create. For a long, long time, those two skills have kind of been at odds with each other, but this new approach, well, it could finally bring them together. Let's dive in. Just take a look at this image. It's incredible, right? An AI can generate stuff like this pretty easily these days. But here's the billion-dollar question. Can the same AI that creates this image also fundamentally understand what it is? For the most part, the answer has been a big nope. You'd get a model that was a great artist or one that was a great analyst, but never both. This new research basically asks, why can't we have both? Okay, so here's how we're going to break this down. First, we'll get into the core problem, what I'm calling AI's three-way challenge. Then we'll look at why the old tech just couldn't keep up, before we introduce the star of the show, UniWeTok, and its secret sauce. After that, we'll check out the test results, and then wrap up by talking about what this all means for the future of AI. So, if you want to build an AI that's truly multimodal, one that's totally fluent in both the language of images and the language of text, researchers have been stuck in this constant tug of war. It's this tricky balancing act between three different goals that just don't want to play nicely together. And here they are. Number 1, high-fidelity reconstruction. Can the AI look at an image and recreate it perfectly, pixel for pixel? Number 2, complex semantic extraction. Can it go beyond just seeing a bird and understand the concept of a phoenix made of fire? And number 3, generative suitability. Can it then take all that knowledge and create something totally new and amazing? Getting an AI to do all three of these things well at the same time, yeah, that's been the holy grail. Now, before we see how UniWeTok pulls off this magic trick, we gotta understand the key piece of tech that's been the big roadblock for so long. It's a little something called a visual tokenizer. Think of it like this. An AI doesn't see a picture the way you and I do. It needs a translator. A visual tokenizer is that translator. It takes an image and breaks it down into a bunch of little visual words or tokens, a language the AI can actually read. And of course, the better that translation is, the smarter the AI can be about the image. And that's exactly where the problem was. The old tokenizers were specialists. If you wanted that perfect pixel-for-pixel reconstruction, the visual words it created were too literal, just too noisy for the AI to get the big picture. But if you wanted it to understand the deep meaning, it had to simplify everything, throwing out all the fine-grained details you need to actually generate a new image. You were always making a trade-off, and you always lost something important in the translation. The dream was to have a tokenizer that didn't compromise. And that brings us to UniWeTok. Researchers from ByteDance and a handful of top universities got together to build this thing, a unified tokenizer designed from the ground up to finally solve that three-way challenge. The key word here is unified. It's everything. The whole point of UniWeTok is to build a bridge right over that gap we were just talking about. It creates a single visual language that's detailed enough for perfect reconstruction, meaningful enough for deep understanding, and clean enough for amazing generation, all at once. Okay, so how on earth does it actually do it? Let's pop the hood and take a look at the secret sauce, because this is where it gets really, really cool. It all starts with a number that is just mind-bogglingly big. 2 to the power of 128. That is the size of UniWeTok's visual dictionary. It's an astronomically huge number of visual words it can choose from. This massive vocabulary is the first piece of the puzzle, because it lets the AI describe an image with an almost limitless level of detail and nuance. But a giant dictionary is useless if you don't know what the words mean. That's where a few other innovations come in. First, they use a clever training technique that specifically teaches the model to pick visual words that are packed with deep meaning. Second, they have another trick that makes sure those words are also perfectly structured for creating new images. And finally, some real technical wizardry under the hood makes it all work together in harmony, preventing those different goals from fighting each other. So that all sounds great in theory, but here's the real question. Does it actually work? Well, the researchers put it through its paces, and honestly, the results kind of speak for themselves. And yeah, the numbers are impressive. On the standard tests for generating images, it's hitting state-of-the-art levels, beating out the previous top models. And for things like image editing, it's right up there with the best of them. The key thing here is that it's not a one-trick pony. It excels across the board, which really proves that whole unified idea. But here's the real kicker. It achieved all of this while using way, way less training data. We're talking 33 billion training tokens for UniWeTok versus a competitor that used 262 billion. That is a huge difference. This shows it's not just about throwing more data at the problem. It's about a fundamentally smarter, more efficient design. And that smarter design unlocks some absolutely incredible creative power. I mean, the proof is in the pudding, right? Look at how it masters these really diverse artistic styles, like this beautiful, subtle ink wash painting. Or check this out. This is a perfect example of its advanced spatial reasoning. You've got the pyramids, the desert, the camel, all contained logically inside a glass bottle, which is itself floating on the ocean. The AI has to understand so many different layers of context to make a concept like this actually work. And the detail? Wow. Just look at the sheer fidelity here. The glowing embers, the intense light from the fire, the texture of every single feather on this phoenix. This is that high-fidelity seeing ability being put to work to create something that's both incredibly complex and crystal clear. And the range is just fantastic. On one hand, you've got this epic, mythical dragon guarding its hoard of treasure. On the other, a totally serene snow leopard in front of a glowing ice castle under the northern lights. It can clearly jump between totally different vibes and concepts without breaking a sweat. So, okay, we're getting some seriously amazing pictures. But beyond that, what does this all really mean? Let's zoom out and talk about why a technology like this actually matters in the big picture. Here's the core takeaway. By finally truly unifying the ability to see, understand, and create, UniWeTok isn't just another incremental update. It's a blueprint for the entire next generation of AI. We're moving away from a world of specialized, single-task AIs and toward a more holistic intelligence that can interact with the world in a much more fluid and human-like way. So what does that actually let us do? Well, imagine editing a photo just by talking to it. Literally just saying, make the sky look like a sunset. Or what if you could take a picture of your living room, show it to an AI, and say, hey, generate a few new decorating ideas for me, but in a rustic farmhouse style. This is the foundation for a whole new class of creative, interactive AI tools. This really just blows the doors wide open for what's possible. For the first time, we have a clear path toward a single AI model that can have a real visual conversation with us, one that can see what we see, understand what we mean, and create what we imagine. And it leaves us with one very, very exciting question. Now that we can actually do this, what are we going to build next?